Thank you for joining this lesson, Longitudes and Latitudes. An aircraft leaves airport P, 50 degrees north and 5 degrees in the west, and flies due west for 2400 kilometers to point Q, then 1500 kilometers due south to point R. Given that the radius of the Earth is 6370 kilometers, this should be kilometers, find part A, the position of Q, then B, the position of R. Let me start by sketching the positions, the relative positions on the Earth's surface of the 3 points. We are having P, 50 in the north, 50 north degrees, and 5 in the west, 5 in the west, 5 in the west. Then now, because this is our P, we will need now to say that we are moving due west. So we will move further to the west to a certain unknown longitude. But now we are moving to the west, which means we are moving along the same latitude of 50 to the point Q. Then from Q, downwards through a known distance to R. Therefore, R is somewhere along this longitude now, the longitude of Q. So let me start by finding position of Q. You know, from P to Q, it is through a parallel latitude or parallel of a latitude. Therefore, we will say distance in kilometers in parallel of a latitude is given by theta out of 360 2 pi r cosine of the latitude. Therefore, a distance which is already known to be 2400 will be equal to change in theta, which is not known, change in longitude out of 360 2 pi cosine of 50, cosine of 50 because the latitude is 50. So now we need to remain with theta by multiplying 2400 with 360 and 7. Then we divide it with 2 and 22, the cosine of 50. This is going to give us, sorry, let me check that. Theta over 362 pi r, sorry. So there is r, radius of the earth. So we're going to have then cosine of 50. So we're going to have 2400 multiplied by 360 and 7, because that is what is in the denominator. Then we divide now by the numerators. Remember, we want to remain with theta. 2 times 22 multiplied by 6370 multiplied by the cosine of 50 degrees. So this is going to give us 33.57 degrees. 33.57 degrees. So we are already at 5 degrees in the west, and we have gone further to the west, 33.57 degrees. So the longitude of Q, now is going to be, when we take 33.57 and we add 3, this is going to give us 36.57. Therefore, the position of Q is going to be, we start with the latitude, 50 degrees in the north and 36 now, sorry, 0.57 still in the west. 50 degrees in the north, 36.57 degrees in the west. This is where Q is. Now from Q we are moving to R, and the distance is known. Remember, from Q now down to R, because from Q to R we are moving southwards to R. It means the distance is along a great circle. Distance along a great circle is given by theta out of 360 2 pi r. So now we have the distance already at 1500 This will be equal to the change in angle, which is not known, over 360 2 pi times r, 6370. So to remain with theta, now we will have to multiply 1500 with 360 times 7, and we divide it by 22 by 2 by 6370. So the change in angle is 13.49 degrees. So we are moving from latitude 50 southwards through an angle of 13.49. This means we are still in the northern hemisphere. We have not managed to be in the southern hemisphere, because if the angle was beyond 50 degrees now, we could have moved the 50 degrees and we enter the southern hemisphere. So we are still in the north hemisphere, and we are going to take 50 minus 13.49, and this is going to give us 36.51 degrees. Therefore, the position of R is going to be 36.51, yeah, because we start with the latitude at 90, and we are still moving along 36.57 degrees in the west. So that is the position of R. Finally, we have a part C, which talks of a ship leaves Mombasa 4 degrees in the south, 40 in the east, and sails due east for 30 hours to a point Q, which is 4 in the south and 52 in the east in the Indian Ocean. Find the average speed of the ship in knots. So we are at Mombasa, 4 degrees in the south, 4 degrees in the south, and 40 degrees in the east. So in the east side, 40 degrees. So this is where Mombasa is. Then we move to a point which is still 4 degrees in the south, 4 degrees in the south, which means if we are moving along 4 degrees south, we are not changing the latitude, 4 degrees south, but we move from 40 in the east to 52 in the east, which means we are moving further to the east. So we are moving along a small circle. So the change from 40 in the east to 52 in the east, the change in longitude is 12 degrees. Therefore, the distance is going to be, again, the formula, times 2 pi r cosine of the latitude. So we're going to have a distance of, the angle difference is 12, because it is from 40 degrees in the east to 52 in the east. This means we can have times 2 times 22 out of 7 times 6370 cosine of the latitude, which is 4. So the distance is going to be 12 multiplied by 2 multiplied by 22 multiplied by 6370 cosine of 4 divided by 360 times 7. So this is going to be 1331.4 kilometers. 0.4 kilometers. But there is a special instruction here. We need the speed in knots, which means the distance should be calculated in what we call nautical miles. So in nautical miles, distance is given by theta multiplied by 60 cosine of the latitude. So we need a theta of 12 times 60 multiplied by the cosine of 4. This distance in nautical miles, instead of using the kilometers now, we're going to have 12 by 60 multiplied by the cosine of 4. This gives us 718.25 nautical miles. Now with distance in nautical miles and the time in hours, we can get speed, distance out of time. So 718.25 out of the time taken, 30 hours, sorry. So divide by 30. Divide by 30. When we divide by 30, we're going to get 23.94 knots, because when nautical miles are divided with hours, we get knots. Thank you for following. Subscribe and share.